Ahmadi. I'm going to present the importance of fuel cell as a part of sustainable development for our community and worldwide. And I would like to start with something which I would like to consider in my presentation. It says that the capacity to learn is a gift, the ability to learn is a skill, and the willingness to learn is a choice. This was given and proposed by Brian Herbert. So what are going to be covering today is about fuel cell. If you remember, last session, we talked about the importance of hydrogen. We just started with why hydrogen is important for us, why we need to consider hydrogen as a prescription for emission reduction, and we discussed about different methods of hydrogen production, ranging from electrolysis all the way down to thermochemical and photoelectrochemical hydrogen production methods. We went through the cost assessment of hydrogen production methods. If you remember, the cost of hydrogen from steam methane reforming was the cheapest one, while the hydrogen production from the electrolysis, where the electricity comes from the renewable sources, depending on the choice, could be something around $8 to $10 per kilogram. So, of course, we just went through the importance of hydrogen, and hydrogen was regarded as the alternative energy carrier. We talked about that one for future due to its higher energy density on a mass basis, and at the same time, it has less environmental impacts. So, of course, the problems and the concerns are about hydrogen was hydrogen is an abundant element in the universe, but the major concerns and drawbacks for that one is we need energy to extract hydrogen from those elements containing hydrogen. And so this is one of the concerns. So of course, hydrogen can be efficiently converted into electricity and vice versa. If you remember the big picture of the hydrogen production and where hydrogen can be utilized and used, we can we can power our homes with hydrogen. We can run our hydrogen fuel cell vehicle with hydrogen. Hydrogen can be stored where we have surplus electricity and different options. So today, we want to consider if we have hydrogen, excluding where hydrogen comes from, if you have a hydrogen in a tank, in a container, how that hydrogen can produce electricity for us. The device which does this task is called a fuel cell. So the agenda for this presentation is going to be followed by some introductory stuff about the fuel cell. Then we went through the thermodynamic and electrochemical of fuel cells and various types of fuel cells. Then, so I don't know whether or not I have sufficient time to cover all of these factors, but I will split it this session maybe into 2 or 3 sessions so students can follow. So introduction, fuel cell. So the most important thing is to know what is fuel cell. So like an engine, a fuel cell is a device where hydrogen as a fuel goes and enter this device, and oxygen from other side enters this black box. We could say consider as a fuel cell here, and it produces electricity for us, and the byproducts are water vapor and some sort of heat. So let's read this one. A fuel cell is a device which converts chemical energy of fuels directly to electricity via several electrochemical reactions. So, of course, the first fuel cell was built in 1839 by Sir William Roberts. These are the 2 applicable hydrogen fuel cell. The one is taken from inside the hydrogen fuel cell car, Toyota Mirai. We will get back to that one in next slides. And this one is another type of hydrogen fuel cell for power generation, stationary power generation that could be used in your house, in your home, and in your residential sectors. So of course, this is why we need to look at new fuels and alternative vehicles, most probably for hydrogen. And this is the important terms in alternative vehicles like gasoline powered hydroelectric vehicles, and they are the most important parts that we are gonna cover today. So let's move on to the next slide. Yeah, when we want to talk about fuel cell, let's see how many patents existed before, and currently they are growing fast and fast. It means that the deployment and consideration of hydrogen fuel cell is substantially improved during the last 1 or 2 decades. So if you look at this graph here, it nicely represents the improvement of the number of patented in three countries. The one is United States, the other one is United Kingdom, and the other one is Canada. If you consider a time frame from 1975 all the way to 2005, we will see that from late 1990 up to 2005, there is a drastic improvement and there is a drastic growth in the patented applications for fuel cell. Then this slide, number of grants patented. And I just updated this graph to see what happened during 2010 and 2011. So you will see the comparison between the granted patented in different countries. It shows that in 2010, Japan has around 600 patents regarding the fuel cell, different types, I mean. But in 2011, they just improved and increased up to more than 1,000. Let's say more than 40% improvement in the patented. So, of course, looking at different countries, Japan is the leading country of the improvement of fuel cell and consideration of fuel cell in the different primary energy sectors. So, followed by Japan, United States. Look at this one, 2010. There were around 600 patents, but in 2011, more than 800 patents. So it shows the importance of hydrogen fuel cell. So looking at the fuel cell, we need to know which kind of engineering disciplines are involved in the fundamental and research and patents related to fuel cell. If you look at here, fuel cell, as I mentioned, is an electrochemical device. Thus, we need to know electrochemistry. Then we need to know thermodynamics. We need to know reaction kinetics, heat and mass transfer, of course, fluid mechanics, and material. Without materials, you cannot produce electricity. So the material. So I would like to say that there are several engineering disciplines here: mechanical, chemical, electrical, and material engineering. Then, considering all of these factors, we have specific fuel cell phenomena, transfer phenomena, and assembling of this fuel cell, either for your car or for powering your home. So, fundamental advantages common to fuel cell system. A potential for a relatively high operating efficiency, scalable to all size power plants. If hydrogen is used as fuel, pollution emissions are strictly a result of the production process of the hydrogen. These fuel cells do not have moving parts, with the significant exception of pumps, compressors, and blowers to drive fuel and oxidizer. So multiple choices of potential fuel feedstock from existing petrochemical, natural gas, or coal, and even renewable energy sources. A nearly instantaneous recharge capacity compared to battery. So we will get to that one. What are the main differences between fuel cells and batteries? Another one. So of course, we need to consider that the fuel cell is not going to be considered as the panacea for every power generation. So meaning that we cannot just replace all the power sector that we have with fuel cell as they produce electricity. We need to look at different options. This one here, alternative materials and construction methods must be developed to reduce fuel cell system cost to be competitive with the automobile combustion engine. So of course, the fuel cell, if fuel cell, we are saying that fuel cell is promising and it has a lot of technology and it's a good option to be considered for sustainable development. Okay, why, if it is good, why fuel cell has not been deployed worldwide and globally? Of course, because of the cost, high cost, and several barriers that we will be facing in future. One is the cost. If it is going to be cost competitive for transportation sector with internal combustion engine, the cost should be around, let's move to this pointer option, and this should be around $30 per kilowatt for transportation sector, and for a stationary power generation should be around 1,000 per kilowatt. So the other one is cost. The cost of the catalyst no longer dominates the price of most fuel cell systems. So why the fuel cell cost is high? Because they use platinum, and platinum is a rare material in the world, and the extraction and the use of that one is a expensive process. This is why the fuel cell cost is expensive. The other one is suitable reliability and durability. Okay, the another concern and drawbacks of using fuel cell is the degradation mechanism, meaning that since the chemical reaction takes place in the MEA, membrane electrode assembly, what will happen because of the chemical reaction, these membranes and these different compartments of the fuel cell stack will degrade, meaning that they just drop their efficiency with time. So the DOE, Department of Energy in the United States, has set a target for a small size vehicle, meaning that if this hydrogen fuel cell car is going to be cost competitive with internal combustion engine, they need to withstand up to around 5,500 hours. Otherwise, these kind of fuel cells cannot be used. So what are the drawbacks? And the performance of every fuel cell gradually degrades, as I mentioned. So what are the reasons of the degradation of all kinds of fuel cells? So assume you are driving your car. Acceleration, deceleration, start, stops. Look at the environment. We will get back to all of these factors. So these factors influence the performance of the fuel cell, which eventually results in the decrement of the performance. So one is load cycling, freezing and thaw, humidity changes in the fuel cell, radical scavengers, because since the reaction is hydrogen plus oxygen, then in some cases H2O2 might produce, and some radical attacks to the membrane compartments will occur. So this is called radical scavenger. And radical attacks, mechanical stress, and corrosion. They are some of the major factors influencing the performance of the fuel cell, which results to gradually degrades with time. As an example, this was taken from Hyundai company, what I used to work with. So what is this one? This is the output voltage of a fuel cell. So it is not given. The data is not provided because of the confidentiality. So since it was confidential, they didn't provide any numbers there. But it shows that over a mileage or a kilometer where it is representing at the same time over. So when the hour advances, the output voltage of this fuel cell stack will degrade. And there is a protocol saying that if this voltage degradation dropped more than 25% of the beginning of life, 25% BOF, beginning of life of this fuel cell, this fuel cell is no longer active for us. We need to replace that one, and we need to remove it from the engine or from the CHP system and bring a new one. So currently, fuel cell for transportation, depending on whether or not it's light duty or high duty, so they have different protocols. For light duty, as I mentioned, it's 5500, which is equal to around 140 miles. So a stationary fuel cell must withstand over 40 hours because they are just for the power generation, like a power plant, which has a age around 20-25 years. So some other factors that we need to consider. What are the other major concerns? Storage, generation, delivery technology must be advanced if pure hydrogen is to be used. Desired performance and longevity of the system components must be achieved. Another one, sensors and online control monitorings for fuel cell systems are needed, especially for transient operations. So let's compare electrochemical engines versus internal combustion engine. So on the left side, we have internal combustion engine here, and on the right side, we have electrochemical, like a fuel cell. So primary energy engine type. This is internal combustion engine. Right side is based on electrochemical. Both energy conversion. One using thermal energy, the other one uses chemical energy. So what about the exhaust? If we know that the exhaust of our internal combustion engine is mechanical power, shaft work, and heat loss, some as an exhaust. But on the other side, we have electrical power, directly electricity, not mechanical shaft, and heat loss. The other important one for fuel cell is the byproducts of fuel cell is water vapor. It's not gonna damage the environment. This is why fuel cell is considered as one of the environmentally benign power generation, not life cycle assessment. I mean, in the production phase. So these are the differences between a combustion engine and fuel cell. So this is like your engine in your vehicle that you drive every day. And this is from GM, General Motors. Conceptual comparison of efficiency of fuel cell versus combustion engine. So let's see the differences between a battery and a fuel cell. Okay, if you remember our experience based on the battery, because we have seen a lot of batteries types ranging from your laptop, your cell phone, your clock, your remote control in your home in order to just turn on your TV. So you have a common experience of how bad batteries are. But what about fuel cell? So as a simple example, if I drill a hole in a battery where fuel can be entering this battery, it is kind of fuel cell. So look at this one. In battery, when used to power a particular application, the fuel and oxidizer react to generate current, chemical products of the reaction, and this continuously deplete the reaction during operation until the performance becomes unstable. So this is how batteries work. And this is a lithium-ion battery. So our intention is not just about the battery. This is another specific field. You can go through and read a lot of details about different types of batteries. Here we want to shed light on the importance of fuel cell. So similar to battery, a fuel cell is similar to battery, except with constant flow of oxidizer. In this case, commonly air and fuel, which could be hydrogen, methanol, or other fuels. Why? Because it depends on which type of fuel cell you are going to select for your applications. So this is the one that I mentioned. Imagine creating a fuel cell by drilling holes in the battery to allow a flux of oxidizer and fuel in and out. So these are the main differences. So let's see, in thermodynamics, we have a system and we have a control volume. If you want to compare which one is battery, which one is a fuel cell, look at here, this one here. We have fuel cell. Fuel cell is like a control volume where mass flux, where mass flux is permitted. While battery is like a system in thermodynamics where no mass flux is permitted. So fuel cell versus battery. One is a system approach, the other one is control volume approach. So fuel cell stack. So of course we will go through these ones later on. This is just as a simple example. This is a PEM fuel cell, proton exchange membrane fuel cell. These are the different compartments of the fuel cell. We have channels, we have MEA, we have the catalyst layer, we have GDL and MPL. But in a simple word, let's consider this one as a black box and a control volume. Hydrogen comes from anode, oxygen from air enters the cathode. The electrochemical reaction takes place and electricity is generated, and the hot H2O is going to be a byproduct. Here, this is the channel we are used to transport fuel and oxidizer, which is in this case oxygen, into the fuel cell. The materials for that can be either graphite or steel. However, in fuel cells, it is better to use graphite to enhance the efficiency of fuel cell. So let me just check to see if it works properly. Okay. Let's go to fuel cell classification. So similar to other fields, we need to divide and classify fuel cells. So fuel cells generally divided into different categories and two different classifications. One is based on the operating temperature, the other one is based on electrolyte type. So electrolyte type classification is, for example, SOFC, solid formic oxide, PM, flexible polymer electrolyte, and alkaline, water, potassium hydroxide in solution. What about operating temperature? We have low temperature and we have high temperature. So each of these has different applicability. For example, low temperature is like alkaline and PM fuel cell. They have rapid startup and higher efficiency. This is why in hydrogen fuel cell vehicles, we use proton exchange membrane. Why? Because when you want to get into your car, what is the most important part for you? It's just as long as you just turn on the vehicle and just do the start, it's going to be just running for you. And the other one is higher efficiency. The higher efficiency is another factor for you affecting your decision. This is why this is what we need to consider for this type of fuel cells. When it comes to high temperature, we have solid oxide fuel cell and we have molten carbonate fuel cell. They use raw material and their cost is lower considering other fuel cell types. So these ones here, low temperature, they require more expensive catalysts and much larger heat exchangers. This is why they are more expensive compared to high temperature fuel cells. So look at this one, fuel cell types, description and basic data. So look, we have alkaline fuel cell, we have phosphoric acid fuel cell, we have solid oxide, we have molten carbonate, and we have polymer electrode fuel cell. Look at the ranging temperature. They just range from 30 to 100 up to 1,000 degrees for solid oxide fuel cell. If you look at the electrolyte type, let's again go to the pointer option. Electrolyte material, here the solution of potassium in hydroxide in water that I mentioned, here uses flexible solid PFSA, and this one is molten alkaline metal, LiK, with potassium and LiNa. And solid oxide fuel cell is just using this electrolyte material. So advantages. Look at the advantages. The advantages of PEM, as I mentioned, low temperature. So this needs to be safe when you want to drive your car. The safety is one of the major important factors for you that needs to be considered. High efficiency, as I mentioned. High hydrogen power density and rapid startup, as I mentioned. If you look at solid oxide fuel cell, these two types are the most well known and they are commercialized. This is used for CHP applications, while this one is used for transportation applications. So the advantage is CO tolerant, fuel flexible, and inexpensive catalyst. So what are the disadvantages? Long startup time. So it takes a lot of time to be started. While this one, the drawbacks and the disadvantages is expensive material. Most promising application. This one is for stationary power generation like cogeneration and trigeneration. This one is for automotive application. So if you're asked to classify the type of hydrogen fuel cell, you would say that there are two major classifications. There might be other classifications. Everybody could just classify because they're experienced. But in most of the references, there are two classifications type. One is based on temperature. The other one is based on electrolyte type. So based on electrolyte type, we have alkaline, we have SOFC, we have molten carbonate, and the other one is based on temperature, high temperature and low